Okay, in 5-5, they're adding on 2 more shortcuts. So let me back up to before the quiz. On Monday, so forget yesterday's lesson because I can understand why they put it there, but it would have made more sense to have it earlier in the chapter because we weren't doing proofs in 5-4. So in 5-3, you did side angle side. That was the only shortcut they showed you. I told you there are other shortcuts. So if you take the combination of 3 with sides and angles, you could have all sides, you could have all angles, you could have this one where you have 2 sides, 1 angle, or the A is not included. So you could have this one, which is the same as this, hence why they would write it backwards, okay? Or you could have 2 angles, because this is 2 sides. If you have 2 angles, you could have this scenario, or you could have this scenario, which is the same thing as this one, but it doesn't spell anything funny, so we kind of go alphabet. They don't want to go alphabetical order on this one because of what it spells, where this one you might as well go alphabetical because it's not anything unique. So these are all technically the different combinations of 3 that you could have in a triangle. The problem is some of these don't work, okay? So I can tell you right now, angle, angle, angle. If you look at your note packet, you don't see that one. Because think about it, if I just gave you 3 angles, now it does have to total 180. So we won't make it too difficult. How about 100 degrees, 60 degrees, and 20 degrees? If I handed each one of you a protractor and said, draw me this triangle, would your sides be the same? Would they be relatively the same triangle because the angles would have to be the same? So they probably would be a dilation from each other, wouldn't they? Some of you might draw like short sides, some of you might draw longer sides. So they would be relatively similar, but they would not be congruent. This chapter is about what makes a triangle congruent to another triangle. So AAA, as I call it, might be a good company, but it's not a good property to use. So in our class, we don't use AAA, okay? So we had this one in 5-3. In today's lesson, they go over this one, side, 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 and they go over this one. Those are the 2 that are in today's lesson, 5-5. And then these other 2 that are left over, these are in 5-6. And then we're skipping the other last 2 lessons, which the 5-7 we're kind of going to do. I just wasn't going to give you homework. 5-7 is what happens when you mix them all together. So we're going to do that on Friday. I just wasn't going to like assign you homework for it. I just thought I would post a picture of a whole bunch of them all mixed together, and then you just have to tell me which property it is. 5-8 is I'm actually making up an extra credit paper for you. So the 5-8 lesson, just kind of due to time, since we don't have time, I'll give it to you on Friday. And if you want to complete, it's only 2 questions. So it's not like I'm giving you all of the 5-8 lesson. I'll give it to you on Friday, and if you want to work on it over the long, weekend or whatever, then that'll be some extra credit. All right? So do you kind of have an idea where they're going with this? Yes? Okay. So first property, side, side, side. Pretty self-explanatory. If somebody gives you 3 sides of a triangle, like if I were to write down some numbers, so like if I were to say to you 3 centimeters, 4 centimeters, hey, we'll just make it easy, 5 centimeters. If I was to write down those and hand you a ruler, and I was to tell you to draw that, all of your triangles would look exactly the same. Now, some of you might have it turned or flipped or on a different angle, but they all would be the exact same triangle, okay? So that's a pretty easy one to pay attention, or to spot. This one is a little harder. And it's HL. And you might be thinking, wait a minute, you didn't have that combination up here. And it's true. I never wrote HL as a combination because if you think about SA, sides and angles, it's not HL. So here's the problem with this property that you guys really have to pay attention to, okay? Different combinations of this. Does everybody realize I could have wrote that the other way, correct? Just probably not the best thing to post up on the board or whatever. So if the angle is not included, do you see this picture? Do you see how the angle is not between the two sides? So this is technically angle, side, side. The A is physically not between them. This property has problems. If I were to give you a combination, 8, 7, 60 degrees, and I was to give you the equipment and say, draw this. There's actually 2 different triangles you could draw me. And I have thought about giving you the equipment and having you try it, but sometimes I just feel like that burns up a ton of time. Our book was written for semesters. So if we were on semesters instead of trimesters, we might probably actually do it because we'd have more time to do it. But it might take some of you a while to figure out how to draw it. So I did it for you. You see my drawing? 8, 60, and then look at my 7. You could actually have that side of 7 be in 2 different locations. Notice angle, side, side. That's the property. But what if I gave you a different combination? Now, do you see how I have some eraser marks? It took me a little bit to find the combination that does work. Because I don't know every combination between 0 and 180. I know I'm a nerdy probably teacher, but I don't have that much free time. I don't memorize just every random angle out there. I mean, I do have a life, okay? So it took me a while to hit on the combination that worked. But if you look, if I do 4, 4, 45, there's only one triangle you can draw. You cannot swing this 5 anywhere else. So the problem with this property is, depending on what combination of numbers people pick, it may work and it may not. So then you're kind of in a bind because you're I don't really know. So this really isn't a great property. But what if this angle's 90? If this angle is 90, it really doesn't matter. Now, do you notice from my 2 pictures, I did have to put the 7 on the bottom instead of seeing how I started with the 8? Pythagorean's theorem tells us that the hypotenuse is longer than the leg. So I really couldn't put the 8 on the bottom, but it's still angle, side, side. Angle, side, side. See how the 4 and the 5 one I did the same. Okay? So this is what I'm telling you. In summary, this property, SSA, ASS, this property, this only works if you have a right triangle. If you don't have a right triangle, you should not use this property. So the book then, or I don't know if the book necessarily, but the field of math decided that ASS probably was not the best abbreviation. And so they decided to call it HL, which stands for hypotenuse leg. But if you look, it's essentially ASS. It really is. Okay? So, thank you. Every now and then I'll still have someone write down ASS. I don't know if they think it's funny or whatever. But I would give it to you because technically that is the property, but the answer key is going to say HL. So that's how it falls in today's lesson. So this is really HL, okay? So we only have a few problems here. If you look down below, they just want to see if you can identify which property it is, and then there's just 2 proofs on the back. So I apologize that today's problems are not very numerical. Yesterday I feel like they asked you to find X or angles and stuff like that. Today's not very numerical. So if you look at number 1, and this is like the best case scenario, it looks like the triangle just slid over. It's like a translation. But I've got side, 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 side. So I would say yes, side, side, side. So you actually have 4 options to answer here. You can say no. If you say yes, you either need to tell me Monday's or today's. So 4 options. Okay? So take a look at number 2. I would agree the 7s and the 9s, correct? But look at those 3 and 4. That breaks the pattern, doesn't it? So all you have to do is say no and move on. You don't have to explain like why it's a no. You just say no and move to the next one. So why don't you see, it should only take you, maybe a minute. Jot down your answers for 3, 4, and 5.
It doesn't necessarily matter where you start. What matters is if the angle is what we call included. So is the angle between them? So then it doesn't really matter that this might be SSA and this might be ASS. What matters is that the A is not between them.
Oh, so no.
Well, this is what? Because it's a right angle, it does work. So I would give you this, but your book is going to say
Yeah.
Okay, here we go.
Or angle
Number 3, hopefully you got, would be yes by side, side, side again. Number 4, Haley asked me a really good question, so I'm just going to kind of point it out because I think there might be some of you maybe wondering this too. She kind of asked, where do you start? And honestly, it doesn't matter where you start. You can start on the left or the right. It doesn't matter. What ultimately matters here is the A between them? So is the A what we call included? And the answer is no. So then you do the other one and you ask yourself the same thing, like does it match? And so you're like, yeah, they match, but they're just in a way kind of backwards of each other, but that's okay. This is the swear word, which is normally bad, but because it's 90, we say HL. So we would say, yes, these are congruent because of HL. If that was not a 90, if it had like a little arc, like a little angled one, I would say no. But because it has the 90-degree mark, Pythagorean's theorem tells us C squared, B squared, we know they're going to be the same, okay? 5. 5 right now in your brain is probably a no. But if you remember my paper there, wherever my paper is, here. If you look at my paper, it's the one from tomorrow. So it's angle, angle, side. Do you see how the side is not between them? So in my brain, this is a yes because it's angle, angle, side. But if for today's purposes you want to say no, you can. Again, my thought was on Friday, I'm just going to mix a whole bunch of them together and just have you identify them just to get more practice, okay? All right. Your favorite thing in the whole wide world. Proofs. Now, let's do one together, and let's have you try one on your own. Because again, sometimes when kids go through them with me, they're like, oh yeah, that wasn't so bad, and then they get by themselves, and they're like, I don't know what I'm doing. Okay? So, this is a really long given, so let's just cheat. We'll carry it down. I'm going to fill in my last step here with my triangles. Now, if you remember the quiz yesterday, you could guess this spot because you only had one choice. But now you have 3, sort of 4. I'll write down the 3 choices. Monday's, or the one you used yesterday on the proof, and then your 2 choices from today. The 4th choice, I hope nobody picks because it would be really hard, is definition of congruent figures, but then you have to show all 6 parts. I mean, why do you want to show 6 if you could show 3? So we don't want to pick that other option. My suggestion to you, if proofs are difficult for you, is start at the given and don't jump around. You ready? B is the midpoint of CD. So if you look at CD, this would be equal to this. The left and the right would be equal. So you just have to state that. The left side is equal to the right side. Now, yes, I reversed my letters because technically if you fold this over, you know, the D goes to the C. But if you put B and then D, it's not that big of a deal. But what do I put for my property? Yep. All right. Now, again, I'm just going straight through the given. All right, AB, EB, they already have it, but I'm just darkening it in to like help my brain like mentally process. Didn't we see this practically the same yesterday on the quiz? So remember, if you're going to say, now don't write this because I'm going to end up probably erasing it. If you're going to use this property, that means that angle C is equal to 90 and angle D is equal to 90. You would have to add an extra step to say they're equal to each other by substitution. But if you remember the one from yesterday, like the one that was on the quiz, right? Right angle congruence theorem. It's from chapter 3. So the right angle congruence theorem, which you can abbreviate at least a little bit if you want. The right angle congruence theorem from back in chapter 3 tells you that they're equal to each other, like this. So then if I go up to my picture, okay, these 90s were already marked, just to kind of reinforce in my brain where it's located. Notice it's not included, so I don't want this choice. I don't want this one because it's not included. It's clearly not side, 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 right? Because it's an angle. So it's not this one. It is the swear word. So if you wrote down ASS or SSA, I would have to give it to you because it is. It's just because it's a 90, that's what they want you to use. Okay? Just one quick comment before you guys try this next proof. So everybody listen. If math and if proofs are difficult for you, it would not be a bad idea to take a blank sheet of paper and every time we have a justification, like make like a huge running list of all of the justifications besides the word given. So anything that we've been using in this chapter, I mean, we haven't been using definition of complementary, right? It's going to probably show up on the exam, but it hasn't been in this chapter. So it might not be a bad idea to keep like a running list of all the properties, so that way when you go to study for the test next week, Wednesday, that's when the test will be, is Wednesday next week, that you kind of have like a word bank to use, to reference from, okay? All right, why don't you try that last proof? Okay, keep going. Okay, you got your thought? I'm going to grab a better pencil because I don't like that one. Now, before I start this, please know there are a couple different ways I can actually solve this because they almost give you too much given. I don't know if that's a good or a bad thing, but here's the problem. Is whoever I pick, how they start us off, it could be different. Like last hour, a kid picked something, and then another kid said, I used a different property, would mine be wrong? I said, it depends on what you wrote down. So this problem, this one can kind of go different ways. So obviously we know the given. Okay. How about Emma?
Okay.
What did you do first?
I did AD to BD.
AD to BD, the bottom? Okay. And this is congruent to this, and you said definition. Okay, be careful because it says that it bisects it. Definition of bisector, I don't know. You can just say to bisect if you want. Okay, so you've got this part. Okay, what'd you do next?
Okay, I got kind of lost, but like I did CDB is congruent to CDA.
Hold on, CDB, this angle?
Yeah.
There's really no way to justify these two though. Because unless you know that it comes down perpendicular, you don't necessarily know that this comes down at a certain angle. Like there's no justification for that.
But isn't that what bisect is?
Bisect means it just split the side in half. Like for instance, I don't know if I can draw this. Let's see if I can draw it better. I'm trying to over-exaggerate it. So let's say the midpoint of this would be like right here, roughly. So if this comes down and it bisects, does it necessarily mean that these angles are equal? So just because the segment is bisected doesn't necessarily mean that these are. Now, that actually, you're kind of, in a way, in the next chapter, talks about the difference between an altitude and a median. And that's the difference. One of them comes down 90, one of them doesn't. So you don't know that, so you don't want to make any assumption about this angle. But there's other stuff we can still do.
Alright, so that's important. It's like we do.
Well, let me give you, City.
We do CA
CA to CB?
Yeah.
Yes. So you just said the left side is equal to the right side. Okay? So CA to CB, which is Y.
Definition of isosceles.
Correct. An isosceles triangle tells you it has two equal legs. Now, everything that she's doing so far is great, but this next step is going to be crucial to your property. And I'll just kind of give you a heads up. Here's your two options. Do you use this as reflexive, side, side, side? Or do you say the base angles, side, angle, side? You would almost literally have to pick here. Like, I think in today's lesson, they want you to do side, side, side so that you're giving an example of each theorem. But if you said the base angles, I couldn't tell you you're wrong because both would work. So this would be literally up to you. And this is as a teacher, one reason why I'm very jealous of history teachers who run those scantrons through to grade their test. And it's just like, boom, they're done in a matter of seconds, where I'm looking at everybody's letters and everything. So what would you want to do? Side or angles?
I'm gonna do reflexive.
Okay, so then you would say CD is congruent to CD. So then your two triangles are congruent, which you guys can fill in the letters. But if you notice, that's then side, side, side. So this step, and then I'll answer your question. This step, now that could have been listed earlier. Maybe somebody said reflexive right off the bat because that's just where their brain went. That line right there is crucial to determining what this becomes. Okay? So again, I'm almost nervous to like show you my answers tomorrow because what if you picked the base angles? My proof's going to look different than yours. Okay?
So if you were to do the angles,
Yep.
what would your reason be?
So here, I'll jump to this pen. So I would say angle A is congruent to angle B based on the base angle theorem. I don't have the entire note packet here. I'm gonna grab these. This was yesterday. Remember base angle theorem? If you're isosceles, then the base angles are congruent. And then it just would change, and I think I saw it on your paper, your property there to this. Okay?